Hello there. These notes are for day 3 in advanced algebra. They cover graphing trig functions like sine and cosine with amplitude changes. So we are going to take a look at y equals sine theta first. You can see here what we're graphing. Now you know how to find sine of 0 degrees and sine of 30 degrees. We've practiced this lots. I went ahead and put stars by your quadrantal angles. You just learned how to find sine and cosine of those angles. However, we are going to use a calculator to complete this table for now. When we graph these in the future, you won't need this huge table. We are doing this just so we can really see what the curve looks like, because the more points we have, the more accurate it is. So I went ahead and calculated all these values using a calculator. I will be rounding to the nearest tenth, so you can just fill in the values as I do. Sine of 0 is 0. Sine of 30 is 0.5. Sine of 45 is 0.7. 60 is 0.9, and sine of 90 is 1. Then we will kind of see the same pattern, 0.9, 0.7, 0.5, and 0. So it increased up to 1, and then it went all the way back down to 0. And now we're going to drop into the negatives. Negative 0.5, negative 0.7. And again, I'm getting these from a calculator. All right. Now, if you use a calculator, I did mention at the beginning, you need to make sure that your calculator is in degrees. So it'll say DEG on the screen. If it's in radians, it will say RAD, and you need to switch it out of radians and put it in degrees. And if you're not sure how to do that, you can honestly search it on the internet or email one of us or your advanced algebra teacher, and we can walk you through it. So if I plot these, sine of 0 is 0, 30 is 0.5. 45 is right here between 30 and 60, and it is at 0.7. Then 0.9, and 90 is at 1. So it's kind of have to be careful. You skip all the way to 30, then you do 45 and 60, and then you skip all the way to 90. And we know from the table that this pattern basically repeats, or it's like a mirror image on the other side. Okay, so right now we have several points plotted, and you can really see the curve. I am going to connect my dots now, and I do have to turn my paper to make it go a little bit smoother. Just hold tight. All right, so I have sketched in a little bit of the sine curve. I am going to hop over to Desmos so I can show you this. The sine curve actually goes on forever in both directions. So I can scroll all the way this way and it just keeps going. You can see it crosses the x-axis at 0, 180, and 360, just like ours. I can go this way and it does the same thing. It goes on forever. So from what we have graphed, you might think that it's just that little section. However, it is not. I actually started putting an arrow on the end already. So I put the arrow to show it goes on forever. And then I can actually sketch this in back here, and then I'll put an arrow. So it would look like this. And again, I will try to do it without, I need to turn my paper, sorry. Turn this. Put an arrow on the end, and that shows that it goes on forever in that direction. So there is y equals sine theta. In pink, you can see that it bounces back and forth. It goes up to 1, down to -1, and it will continue to do that. So the highest point it will ever reach is 1, and the lowest is -1, and I'm referring to the y value. So 1 to -1. Now, we have this line that we call the midline, and it goes right through the middle of your graph. It is a horizontal line, so I use a ruler. That right there is your midline. So from your midline to the greatest value is a distance of 1. And from the midline to your smallest value right here, so this distance is also 1. So that's how you know it goes right through the middle. Again, it is called the midline, and it's right there on top of the x-axis, so it has the equation y equals 0. So right underneath the graph, it says, what is the equation of the midline? That is y equals 0, horizontal line. All right, now we are going to consider the graph y equals 2 times sine theta. The only difference between the sine theta graph and this is the 2 out front. So if you look at the table, these are my theta values. These are my sine of theta values. In other words, sine of 0, sine of 30, sine of 45, and so on. So if I want this down here, these theta values are the same as my first table, but now I need 2 times sine of theta. Well, I already calculated sine of theta up here, so we're just going to multiply all of these values by 2, and that will give me 2 sine theta. So if I do that, I have 0, 1, 1.4, 1.8, and 2. And then we follow the pattern here down. Now we have negative. Remember, I'm just taking these and multiplying by 2. So -1, -1.4, -1.8, -2, -1, and 0. All right. So if I graph this on the coordinate plane above, I see that I am at 0, 0 still, but at 30 degrees, I'm at 1 instead of 1/2. 45, I'm at 1.4. 60, I'm at 1.8. And then, I think I got that a little high, 1.90, I'm at 2. And then 0, and then down here, okay. You can see the difference. This is going to reach higher, and then down here lower. So it has a bigger range. It goes from -2 to +2, where this one went from -1 to +1. So if I sketch in my curve, and this first point I got a little bit, that 1 point's a little bit high. Got a little off there, but that's okay. All right, so there is my, I definitely missed that point right there. It's okay. All right, so there is my 2 sine theta graph. And then if I kind of copied back here, it would look like this. Okay. So again, I have a bigger range. It is a total from -2 to 2. It covers 4 y values. All right. So if I kind of think about transformations here, what happened from my original sine to my 2 sine theta graph? Well, the 2 stretched it. So I took these and I stretched them up and down. So the 2 will stretch the graph of y equals sine theta by a factor of 2. And I'm going to write right underneath here that it stretched it vertically. All right, so the equation of the midline of this graph is still going to be y equals 0, and that's because y equals 0, or the x-axis, still is right in the center of my graph. All right, so if I now look at y equals negative sine theta, you'll see the 2 is no longer there. It's a -1, or just a negative sign in front. And we're going to do the same thing. We're going to take our original sine table, so where the pink values are, and instead of multiplying them by 2, now I'm going to multiply them by -1, which means I'm literally just going to change the sign of all of them. So these will all become negative, and these will all become positive. So if I do that, my table looks like 0, -0.5, -0.7, -0.9, and -1. Then same values, and then these ones will be positive, 0.5, 0.7. All right, so now if I hop back up top and I graph this, it's going to have the same shape, but it will be on the opposite side. All right, so I will sketch that in. All right, so there is that part. Now I have to extend over here into the negatives. So it looks like this. All right, so you can see that it has the same height as my original graph. It goes from -1 to 1, so a total range of 2 there, but it's reflected across the x-axis. So the pink here was my original, it's down here, and then originally my pink was down here, and it's now up there. So this one definitely is different than the original. So the negative will reflect the graph across the x-axis. All right, so same thing, equation of the midline, it hasn't changed. The x-axis still goes right through the center of my graph. I kind of go up and down based off the x-axis. So the equation of the midline is y equals 0. All right, so now we're going to talk about the amplitude, which was mentioned in the title. The amplitude of the graph of a periodic function is the maximum distance it reaches from the midline. So if I think about my graph here, if my midline is that x-axis, then the maximum distance I reach off of that for sine is 1, okay? So that right there is your amplitude. Same thing here. The maximum I ever reach off of it is 1 unit. All right? Now, if you think about the y equals 2 sine theta, the maximum you reach on that one is 2. So I'm going to do that one over here just so I don't go over the top. This amplitude from the midline to the maximum distance you'll go, that's not a maximum, that's actually a minimum point, but the maximum distance is right there, and that is your amplitude there. So that one is going to be 2, where this one is 1. Now the amplitude of this guy is also 1. Okay, so it's the greatest distance off the midline. Well, what you're going to want to do is go from your midline either to a max or midline to a min, and that will give you your amplitude. Now, from the equation, you can actually see it. This A value is critical right here. that actually really, that will tell you what your amplitude is. So if you have A sine theta, the amplitude is just the absolute value of A. And it's absolute value because we're looking for a distance or a length, and that can only be positive. So if you look back at my equation where it was y equals 2 sine theta, the amplitude was 2. If you look at my y equals negative sine theta, well, the A value is negative 1. The absolute value of negative 1 is 1, so that makes sense that the amplitude was 1. So you really can just get it from the equation. And the period is the horizontal distance required for the graph of a periodic or cyclic function to complete one full cycle. The period of A sine theta is 360 degrees. Now think about it. We completed one full cycle from 0 to 360. And after that chunk, my graph is going to repeat. So I am going to hop back on Desmos to show you that. Here is Desmos again with sine. And if I look at these two lines here, you can see from 0 to 360, I have that curve. And then look, it starts again, and it goes from 360 to 720. And there is another cycle of it. So starts at 0, up to 1, down to 0, negative 1, and back to 0. Start again, up to 1, down to 0. And you can see if I there's one cycle, and then there's the second cycle. So every 360 degrees it repeats, which means the period is 360 degrees. Now that will change later on, but for this lesson, the period and the period will always be 360, and the midline in these problems will always be y equals 0. Again, in future lessons, those will change. All right, so moving on to graphing cosine. It is going to have the same shape, and you'll see that in just a second. We also can slim down this table. We don't need to plug in all those values and get all the decimals. We're really just going to have this tiny little table. Now, these are your quadrantal values, and you could technically use a calculator to get all of these at the moment, but I want to show you where they come from. So when graphing trig functions, we really only need to plot the maximum and minimum values. Okay, those are those 1 and negative 1s. And the zeros. We're going to plot the zeros or the x-intercepts as well, and you'll see. So if you remember from the previous lesson, you have quadrantal angles. Now think about your unit circle. There's your unit circle, kind of. And this is 0 degrees, and that is the point 1, 0. That coordinate, if this is the unit circle, the radius is 1, so that point is 1, 0. This one is also up 1, so 0, 1. This one is negative 1, 0. It's not totally to scale, but close enough. And if this is 1, then this is 0, negative 1. Now, hopefully from the previous lesson, you also remember that your coordinates are in the form cosine theta, sine theta. In other words, cosine is going to be your x-coordinate, where sine is your y-coordinate. So if I want, say, cosine of 0 degrees, I go to 0 degrees on my circle, on my unit circle, and I find the x-coordinate, which is 1. So cosine of 0 degrees is 1. Then if I want cosine of 90, I go to 90, and I get the cosine value, which is the x-coordinate, so 0. Then I slide over here to 180. Cosine is negative 1 because the x-coordinate is negative 1. Down here, it's 0. And back here, it's 1. So there's your parent table for cosine. Now, we could have used this on the front for sine. We would have grabbed the y value as we went around. So sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. So again, it's cosine, sine, cosine, sine. For all of these, it's cosine, sine. That one's kind of hard to write in. All right, so if I plot these, I have 0, 1, 90, 0. You can see there's far fewer points, but we know that this is a curve, so it's okay to not plot all of those points. We only did that so we could really see the shape of the curve. I know it goes on forever in both directions, so once I have these points plotted, I can go ahead and connect them. Again, I have to turn my paper. I apologize. Okay. So my graph got really goofed up right there. I'm going to try to get rid of that so it doesn't get in the way. All right, you'll see the whiteout on there, but that's okay. So there is cosine theta. You'll see the shape of it is just like sine. However, it crosses through the x-axis at different places, and it reaches its maximum and minimum value at different places as well. So let me see if I can smooth this out a little bit for you. It's not a huge deal, but... Okay, and we have arrows on the end because we know it goes on forever in both directions. All right, so there's cosine. The period again is 360 because I go 0 to 360 and I start into my next one. It's hard to see on this graph, but think about that Desmos graph that I showed you where it just keeps going forever. So the period is 360. And the amplitude is also 1 because from my midline to my greatest distance away is 1, or down here is 1. And the equation of the midline is y equals 0. So these three things are the same for cosine and sine. Now, once I start putting a number out front, remember some of these values will change. The period today will always be 360 and the midline will always be y equals 0. It's the amplitude that is changing in these problems, and that was the title of the notes, is amplitude changes. So we are going to now look at y equals 1/2 cosine theta. So remember we talked about this number out front being a, and that helps us figure out the amplitude. So I take the absolute value of that number out front, because amplitude is a length or a distance. So it's actually a length, not really a distance, but regardless, we take the absolute value of this number and it gives us the amplitude, which means from the midline to the greatest distance on this graph will be just a half. The period is 360, and I don't get that from the equation. I just know that for right now. Again, if I have cosine values and I want 1/2 cosine values, I just take those up top and multiply by a half. And now I'm going to plot these. So 1/2, 0, negative 1/2, 0, and then positive 1/2. Let me turn my paper. Okay, so you can see the amplitude is much less. That is going to be your amplitude. Remember, you go to your midline and then find a max or min. So there's another one. My amplitude is just a half. And that was, instead of stretching it vertically, I compressed it down, and that's because of the 1/2. Now, the last example here, oh, sorry, we've got to write this in. What is the equation of the midline? It is still y equals 0. So last example here is example 4. What happens when I look at -2 times cosine theta? Well, we should know that the negative is going to reflect it. We saw that on the sine graph. The 2 is going to stretch it. So we've kind of two things going on here. We are going to reflect and stretch. So the amplitude, we know to look at this a value, -2, and I take the absolute value of that. So the amplitude is 2. And the period is 360 degrees. We should be able to write this in already as well. Midline is going to be y equals 0, that x-axis. So take your original cosine values from this parent table up here. This is the parent table for cosine. And multiply them by -2. -2, 0, 2, 0, and -2. Now we plot these. -2, 0, 2, 0, and -2. So you can see this one is definitely stretched and reflected. Let me draw this in. Okay, so there is your y equals -2. So remember, the pink one was my parent graph or my regular cosine. So it's definitely reflected and stretched. So this right here, from your midline to your maximum distance away, or right here, that's your amplitude, and it equals 2 in this case. All right, so hopefully that helps you get started on this lesson. Remember, you're going to get your sine and cosine values from your quadrantal angles. And again, you learned that in the previous lesson. Don't forget, this is your parent table for cosine. Everything you do for cosine is going to come out of this table. We are only changing amplitudes today, which means these y values are going to change. Your x values are going to stay the same no matter what, or they're not technically x values, they're theta values. And then this was your parent table for sine. So maybe write that in. Okay, now it is the parent table, meaning these are the sine values. But if I was to draw a condensed version, which we did for cosine, I would only put these values on my sine table. I would not put, and you do not need to put all the middle values. Again, we did that so we could get several points on our graph, and that would help us figure out the shape of the graph. But if I was to come up with a sine graph now that I know what the shape is, I would just use these 5 values. And again, they come from the unit circle. If you have any questions on this lesson, you can just email your teacher or any advanced algebra 2 teacher, and we can hopefully get those questions answered. Good luck on your homework.